Good morning class 10. Today we will do remaining questions of exercise 6.2. Question number 7. Using theorem 6.1, prove that the line drawn through the midpoint of one side of triangle parallel to another side bisect the third line. Recall that you have proved it in class 9. Actually, this is the statement of converse of midpoint theorem, and with the help of 6.1 theorem, means Thales theorem, we have to prove this. See the statement of question number 8. This time using theorem 6.2, prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. This is also we have done in class 9. This is the statement of midpoint theorem, and with the help of converse of Thales theorem, we have to prove this. Now we will do the proof of both theorems with the help of Thales and converse. Here question number 7, ABC. It is given a triangle in which D is the midpoint of AB and DE is parallel given to BC. And we have to show that E is the midpoint of AC. Now here if D is the midpoint of AB, we can say that AD is equal to DB. And if DE is parallel given to BC, so by using Thales theorem, we can say that AD by DB is equal to AE by EC. Here I have written AD by DB is equal to AE by EC, but is the midpoint of AB. So we can say AD is equal to DB. So by cancel out, we will get 1. So AE by EC will be equal to 1. It means EC is equal to AE. So E is the midpoint of AC. So we have proved the converse of midpoint theorem with the help of Thales. And in question number 8, this is the converse of question number 7. Here ABC is a triangle in which D and E are respectively the midpoints of AB and AC. And this time we have to show that DE is parallel to BC. Now if D is the midpoint of AB, so AD is equal to DB. And if E is the midpoint of AC, then AE is equal to EC. Now if AD is equal to DB, so that we can conclude that AD by DB is equal to 1. Similarly, AE by EC is equal to 1. From both the equations, both the ratios are equal to 1. So AD by DB is equal to AE by EC. From 1 and 2, AD by DB is equal to AE by EC. So by using the converse of Thales theorem, we can conclude that DE is parallel to BC. Now question number 9. ABCD is a trapezium in which AB parallel DC and the diagonals intersect each other at point O. Show that AO by BO is equal to CO by DO. And question number 10. The diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. Now question number 9 and question number 10. These two are reciprocal to each other, or we can say the converse of each other. In question number 9, ABCD is given trapezium, and in question number 10, we have to show that ABCD is a trapezium. So for their proof, what I have done here, question number 9, here ABCD is a trapezium given with AB parallel DC, and we have to show that AO by BO is equal to CO by DO. Now here I will do one construction. I will draw a line EO through the point O, which will be parallel to DC, and automatically it will be parallel to AB. And I will take triangle ADC. Here in the triangle ADC, EO is parallel to DC by construction I have taken. So by using Thales theorem, AE by ED will be equal to AO by OC. Now again I will take triangle ADB. Here again EO is parallel to AB. So I can say by using Thales theorem, AE by ED is equal to BO by OD. But I can also write DE by EA is equal to DO by OB, or AE by ED is equal to BO by OD. In any one of the way you can write, but I required AE by ED, so I am writing AE by ED is equal to BO by OD. Now I have written both the results here for both the triangle, for first triangle ADC and for second triangle ADB. And from both the equation, we can conclude that AO by CO is equal to BO by OD. Here AO by CO is equal to OB by OD, but we need BO here, so we will exchange their position. So AO by BO is equal to CO by DO. This was the question number 9. And in question number 10, here ABCD, it is only given a quadrilateral and we have to show that it is a trapezium. And for proving that it is a trapezium, what we will do? We will prove that one of the opposite sides pair is parallel, and we will show here AB is parallel to DC. And for that also we will do one construction. We will draw a line EO parallel to AB. Now for that I will take triangle ADB. Here in triangle ADB, EO is parallel to AB. So AE by ED is equal to BO by OD. I can write it. According to given, AO by BO is equal to CO by DO. After exchanging their position, AO by CO is equal to BO by DO. But in triangle ABD, BO by DO is equal to AE by ED. From these two, AO by CO is equal to AE by ED. AO by OC is equal to AE by ED. It means for the triangle ADC, we can conclude that EO is parallel to DC by using Thales theorem. But EO was parallel to AB by construction. So we can conclude AB is parallel to DC. If AB is parallel to DC, it means we have shown that for any quadrilateral, the opposite pairs, one of the opposite pair of the sides are parallel. So that is a trapezium. So ABCD is a trapezium. So class 10 for today, you will complete your exercise 6.2 in your fair notebook.